So what a logarithm is it is the inverse of exponential. So those exponential graphs we did, a logarithm is the inverse of that. And this is going to come up later on in these notes, so let's just talk about it now. How do you find an inverse? What do you do? Swap what? X and Y, okay? It's just inverse. You take the input and the output and reverse them. So what it is it's a way to isolate an exponent. So what does isolate mean? And it's like big vocabulary word. Alone. It's a way to get the exponent alone. Mathematically, there's no other way to solve for an exponent. Okay, so that's what you use a logarithm to do. The base number cannot be negative. And do you remember when I made a little table and I said, what if we try to do a negative base with an exponential? Do you remember what happened to the numbers and why it wouldn't work? Like we tried to do a negative base, but it wouldn't work. What was wrong with it? Like, because we tried to do it. Not the reciprocal, but like when we tried to plug in numbers, do you remember what happened to the results? Good, it oscillates, negative, positive, negative, positive, negative. Do you remember that? So it doesn't like make a graph. Your points would be like, it's called oscillating behavior. So anyway, it won't work. So the base cannot be negative. And we have two like special ones. The common base, what's called the common base is 10. And that's because we have a base 10 number system. Do you know why we have a base 10 number system? Like why our numbers recycle every 10? And it does logically make sense. You know how we have 0 and 1 through 9, like it keeps recycling every 10, like you only have 10 digits. Do you know why it's 10? Why don't we recycle them every 5 or every 7? I can't hear you back there if you're trying to answer me. Go ahead. Yeah, we don't have, they don't exist, but why? We have 10 digits. Why are there only 10 digits? You have 10 fingers. Actually, mathematics is just a part of you. It's like in your being. Okay. So anyway, the way we write this, when it's a log base 10, you just don't write the 10. So if you don't see it written, it's understood to be a 10. This is different from everything you've ever seen before, because if something's not written, we always understand it to be 1. But for a logarithm, it's understood to be a 10. Okay, that's your common base. Oh, I'm sorry. I'm a little bit too zoomed in. This projector is a little bit weird. And then the other like special one is called the natural base. And the natural base is E. And so if the base was E, we don't write it like that. The way it's written is ln. And if you saw that ln button on your calculator, remember we did second ln to get the E on the calculator when we did the PERT formula? That's what ln means. It's like log natural, like natural log, but it's log natural, I guess. I don't know. Do you know how like other languages, they put the adjective after the noun? You take other like, you know what I'm talking about here? Anyway, that's your natural log. So we don't write this, we would write ln. What we're going to practice is just writing in log form or exponential form. So this says write in log form. It is just getting each number in the correct spot. That's really all this is. But if it says to write in log form, the first thing that you should write is the word log, okay? And you want to get the base number in the right spot first. Out of these 3 numbers, 2, 3, and 8, which one is the base number? 2. And it's like a little subscript. And I know this is corny as all get out, but the base goes in the basement. So that's like the, like, I know that sounds so stupid, but if it makes you remember it, then I don't care. So it's like the little subscript. It's like an anti-exponent, okay? Now what you're going to do is leave a little gap, put an equal sign, and this is the take-home part. This is what you got to walk away with. It equals the exponent. That's the whole point. It equals the exponent. What does it equal? The exponent. That's the whole point. Okay, so what's the exponent out of all of this? 3. And then the only number you didn't use will go in that blank, which is 8. You're just getting all the numbers in the right spot. This is said log base 2 of 8 equals 3. Log base 2 of 8 equals 3. Let's try it again. You're just getting all the numbers in the right spot. This would be log base what number? 4. Leave a little gap. It equals the exponent. It equals the exponent. It equals the exponent. So what does it equal? -2. And so the 1/16 goes in that little gap. Do you remember this from, you did this in algebra 2? It's one of the last things you do, so it's probably like more fresh in your memory. You did do this in algebra 2, I swear. What is the base for this one? 36. Leave a little gap. It equals the exponent, which is a half. So 6 goes right there. Now this one, you're not going to write log log. Do you see how it's base e? So instead you write ln. That means log base e. Leave a little gap. It equals the exponent, which is 4. And so that 54.598 goes in the gap. The reason it's a decimal is because e is a decimal. It's 2.78 blah, blah, blah to the 4th equals that number. So that's why it's a weird decimal. And then lastly, this one, do you see how it's base 10? We don't write log base 10, we just write log. That's the common log. So just don't put a 10, don't put anything. Leave a little gap, it's going to equal what? 3. And so that 1000 goes in the blank. Now the base 10 ones are nice because we have a base 10 number system. How many zeros do you see? That's why it's 3. It's just the number of zeros. Do you get what I'm saying? No one like ever sat you down and explained that to you. Now it has been done. Okay. Now we're going to go the other way. It says write in exponential form. That means you better have an exponent. Do you understand? Okay, let's all just stay awake and pay attention. What is the base number for this one? Good. 10. The logarithm equals the exponent. So when you see this logarithm, whatever it equals, that's the exponent. So the exponent is 2. So 10 squared equals 100. Now for these ones, you need to make sure it makes sense. Does 10 squared equal 100? Now, if you wrote 100 squared equals 10, I hope that you would go, whoops. You know what I mean? All right, so what's the base number for this one? 5. And what is it? To what power? 2. So 5 squared equals 25. And then you want to be like, hey, is that true? Yes. All right. How about this one? 49 to the 1/2 power. Now that is true. And that's because the 1/2 power, we talked about this last time. The 1/2 power means square root. The 1/3 power means cube root. Okay. So it's square root of 49 is 7. What's the base for this one? E. E to the power 1.945 equals 7. The reason you see decimals with the E is because, again, E is a decimal. It's 2.718 more decimals forever and ever. Okay? And then this one is 2 to what power? 2 to the -3rd equals 1/8. That is because 2 to the 3rd is 8, but the negative means you flip it. Don't go to sleep on me. You got to understand this. The negative means it gets flipped over. All right. We're going to real quick review our exponent properties. You learned these in algebra 1, but it's been a minute. So let's go over them again. When you multiply, you add your exponent. And please don't go to sleep on this. You got to understand this. When you multiply, you add your exponents. Let's just do a little example of each of these. Give me some small numbers, like single digit numbers. Well, 1's not going to help us because you won't see what's actually happening. Let's do 3 and 4. If you have x to the 3rd times x to the 4th, when you multiply, you add the exponents. So that would be x to the 7th. Good. When you, I'm giving you an example of each. Like I have them written on here, but I'm just doing an example. I'm going to do like one example of each of these for you. When you divide, you subtract your exponents. Okay. So if you had like x to the 9th over x to the 7th, what would that give you? 9 minus 7 gives you 2, the x squared. So when you multiply, you add. When you divide, you subtract. That kind of like is logical, right? I think that's what makes sense. Now, when you do a power to a power, you multiply them. So again, give me some little numbers. So x squared to the 4th. When it's a power to a power, you multiply them. So that would be x to the 8th, okay? When it's a negative exponent, you flip it. So if you had 6 to the negative 2, what's that going to be? 1 over 6 squared, which would be 1 over 36. So you do 6 squared and then just flip it. So the negative exponent reciprocates it. Whatever number you have outside of your root is the type of root it is. It'll be a fraction. So for example, if it's a half, it'll be a square root. So say you had, give me a perfect square.
4.
So 4 to the 1/2 would be what? 2, square root of 4. Let's do a cube one. How about 125 to the 1/3? 5, good. Cool. And then you can also throw another number in there. I usually just do a 2/3. Let's say you had 27 to the 2/3. Pretend it's a 1/3. Pretend it's a 1/3. What is 27 to the 1/3? 3, but then you square it. So 3 squared, 9. Okay. Pretend it's a 1/3, but then you just square it. You have to understand the exponent rules to do what we're going to do right here. So when this says evaluate, when you're evaluating a logarithm, let's write this down. Your answer is the exponent. Remember I said that's the big takeaway? You've got to get that. The logarithm equals the exponent. Your answer, what you're looking for, is the exponent. So what this is asking you is 2 to what power, let's get our heads up off the desk. 2 to what power is going to equal 64? Let's count on our fingers. That's why we've got them. 2 to the 1st is 2, 4, 8, 16, 32, 64. So it's 2 to what power? The 6. So your answer is 6. You're looking for the power. Let me do that again. 2, 4, 8, 16, 32, 64. Just counting your fingers. All right. This is asking you 81 to what power will give you 9. Well, it's a square root, so good, 1/2. This is asking you 3 to what power gives you 1/27. Pretend it's a 27 real quick. 3 to what power gives you 27? Be 3, but to flip it, it'll be -3. The negatives are what flip it over. What's the base for this one? 10. So it's 10 to what power gives you that? Good. How'd you get 4? You just count the zeros. It's however many zeros there are. 10 is easy because we have a base 10 number system. This is 17 to what power gives you 17? 1. Anything to the 1st will be itself. This is, oh, good at these. This is 12 to what power gives you 1? And that would be 0. Anything to the 0 power gives you 1. So no matter what the base is, if you see a 1 there, then the answer is 0. Now here, ln and e are inverses. They're going to cancel. And the answer would just be 9. Because 9's the exponent. And the answer is the exponent. I wrote down a couple extras just because of how they do them on Delta Math. They stick a variable in there. So let me just show you a couple more. These are super quick. This is asking x to what to the second. X to the second would give you 25. What number would that have to be? What number to the second? Good. Do you see how that would be 5? That's how they ask them on Delta Math. Let me just do a couple more. They only take a second. This is asking what number to the 3rd will give you 64. What number to, good. Okay, it sounds like you guys have got it. Let me just do one more. This is asking 2 to the 4th equals what? 2 to the 4th power. Let's count on her. Oh, 16. You guys got it without me counting on my fingers. But here, we'll count. 2, 4, 8, 16. Okay, so if they stick the X somewhere else, you do the problem the same way. You're just looking for a different piece of it. All right, so these ones say find the inverse. So look, you want to like foreshadow and think about what your answer is going to look like. If your problem is exponential, and do you see how these two are exponential? Like X is the exponent. Your inverse is going to be logarithmic. The answer should say the word log, bless you, somewhere in it. If the problem is logarithmic, do you see how these are logs? Then the answer should be exponential. Do we get that? Okay. To find an inverse, you're going to switch X and Y. Would sure help if there was a Y in the problem. So scribble out f of X, call it Y. We're going to switch X and Y. Everything else stays put. So it is going to be X equals 1/2 to the Y power plus 1. Here's my pep talk for these. You are going to get stuck. And I know half of you are like, not me, I'm brilliant, I'm not going to get stuck. Yes, you are. That's like the point of the problem. There will come a step where you are stuck. And if you can remember the question that will get you unstuck, you will be fine. The question is, what is the base number? When you get stuck, not if, when you get stuck, you go, what is the base number? Then you will be fine. Does this make sense? Okay. What would you do to start trying to get Y by itself? Because we're not stuck yet. You have -1. Okay, so you have X minus 1 equals 1/2 to the Y power. Now you want Y alone, but the problem is it's the exponent, so we're stuck. What is the base number? 1/2. It is going to be log base 1/2. Oh, sorry. Leave a little gap. And the point is that it equals the exponent, which is Y. Good. So it's going to equal Y. What goes in the gap that we left? Good. The X minus 1. And you want to just give that a hug. Is Y alone? Yeah. We did it. Here's the only thing I like, and you don't have to fix this, but it would make me happy. Since we found an inverse, instead of Y, you should write inverse because that's what we found. It'll just make me happier, but you don't have to do that. Do you see how this next one says E in it? What's the answer going to have in it? ln. Hey, I know, right? Scribble out f of X, put Y, switch X and Y. X equals 2e to the Y minus 7. You're not stuck yet, but when you get stuck, your question is, what's the base? I used to bring up that Meghan Trainor song, you know, I'm all about that base. But like the more years that go by, the song keeps getting older and older, and then no one knows what I'm talking about. Does anyone know that song? Okay, I used to bring it up. Just sing that song in your head. Okay. What would you do to start trying to get Y by itself? Add 7. I should play it while we're like doing our homework or something. Yeah, I guess not. I don't think she says a cuss word in it. Yeah. All right, then what? Still want Y by itself. Divide by 2. So it'll be X plus 7 over 2 equals E to the Y. Then you're going to be like, I'm stuck. And the question is, what's the base? The base is E. Now we don't write log base E. We write, bless you, we write ln, leave a gap. It equals the exponent. That's the whole point. It equals the exponent. So what's the exponent? Y. And then in the gap will be everything else. Just give it a hug. Bless you. And just if you feel like it, if you want to erase Y and change it to inverse, because that's what we found. That's just like the more grown-up way of writing it. I won't mark off on the test if you don't put that, though. If you, for heaven's sake, if you have the right answer. All right. Again, these ones say log, so your answer is going to be exponential. When you get stuck, not if, and you're like, I'm brilliant, I'm not going to get stuck, Miss Cole. No, when you get stuck, the question is, what's the base? Scribble out f of X, put Y, switch X and Y. X equals log base 4 of Y plus 3. Now, I always get asked here, and this is a really good question, Is the 3 inside the logarithm or outside? It's outside because you don't see parentheses. If there were parentheses here, it would be inside. It's a very subtle difference. Do you see that? Okay, but we don't have parentheses, so it's outside. So what's our first step? Yep, subtract 3. And then you're stuck. So what's the base? 4 to the power x minus 3 equals y. But instead of y, if you could just put inverse, that would be super cool. What is this one going to have in the answer? It's going to have e in the answer. All right. Scribble out f of x, call it y. We're going to switch x and y. And you're not stuck yet. What can you do? Subtract 2. Then you're stuck. So what's the base? E. It's e to the power of what? X minus 2 equals y plus 8. And we actually have one more step because y is not alone yet. Yeah, subtract the 8. So it'll be e to the x minus 2 minus 8 equals y, or if you want to put the official inverse notation, you can do that.